Okay, in Chapter 1, Section 5a, we're going to start to tackle the idea of imaginary numbers. Up until now, we've been dealing with the real number system. So real numbers, -1, -2, 3.5, 4.5, all those are real numbers. Now, imaginary numbers, we're going to talk about those, and basically complex numbers are made up of either imaginary numbers only or real and imaginary numbers together. So what is the idea of this imaginary number? Well, whenever we got to a problem that said, what is the square root of 20? We knew, we know the square root of 20 is 4 times 5, and so it's 2 radical 5 or some decimal. But when we got to the question, what is the square root of -20, we would say no solution or do something like this, or we might have even said no real solution, because that's the truth. There's no real number that's going to multiply by itself to equal -20. So anytime you had an even root, like a second root or a fourth root or a sixth root of a negative number, we would say there was no real solution. Well, to kind of solve this problem, they came up with this imaginary number system. And the imaginary number system says that the square root of a -1 is equal to I, okay? And so what happens is now we assign a value to this negative factor, and we're able to do the math now and solve and work with these imaginary numbers. It's pretty incredible how they work. So again, you have to memorize that the square root of -1 is always I, and you have to consider, well, what happens if I square I, right? So you're going to get, if you square I, you're going to get I squared equals -1. So these are the two values that we're wanting you to understand, okay? And then once we have it, we can actually add and subtract, multiply with I as a variable. So you sort of treat it like a variable, except for the fact that whenever you get an I squared, you have to replace the variable I squared, that term, with -1. And I'll show you, and it kind of becomes easy. There's a standard form, like everything else, of writing complex numbers. We put the real number first, plus the imaginary number second. So if I have 2 plus 5i, that's the correct way to write it. We do not write 5i plus 2, okay? This is the way we do it. So let's solve some problems with basic computation with I, okay? So what you're going to do is you're going to combine your real parts and you're going to combine your imaginary parts. So in number 1, we notice the real is 4 plus 1, that's 5. The imaginary parts are plus 7i and minus 6i, and you treat it as if I was a normal variable like an a or an x or anything else. Plus 7 minus 6 is plus 1i, or you could just say 5 plus I. Okay, we go to number 2, same thing. We add our real numbers, 1 plus 3 is 4, and 2i plus -2i cancel. So our solution is 4. Here, again, we just have to be careful with distributing this minus in both of these cases, so I'll rewrite it. 3i plus 2 minus 3i minus 2 minus 5i, and then I go through and I'm going to identify all my i's, right? Those are considered my like terms. 3i plus -3i cancel, leaving me with minus 5i. And then again, I come here and I go to my numbers, my real parts, -2 and a +2, and those two actually cancel out, so I just have a single answer. So again, adding and subtracting with i's are a breeze, or with imaginary numbers. Again, I'm going to expand this out in case there's any minuses here, right? Plus 4 minus I, and I have to distribute that minus 7 minus I. And again, now I'm going to go through and I'm going to look to identify my like terms. I could start with my numbers. +3, +4, minus 7. So 3 and 4 is 7 minus 7. Guess what? They cancel out. And then I'll go and identify my imaginary components to this. And I have 2i minus 1i minus 1i. That's going to cancel as well. Everything canceled, so this just equals 0. Okay. Now we're going to multiply with I. And again, as we multiply, we treat it like a regular variable. So if I was to distribute the 4, I would get minus 8 plus 12i. And guess what? That's the final answer. Super easy, right? When I get to here, I have to FOIL. So again, I'm going to FOIL as if this was any other variable. I'll treat it differently in the end if I need to, okay? So again here, I'm going to FOIL this one. I'm going to do first times first is 8, outer times outer is plus 6i, inner times inner is minus 4i, and last times last is minus 3i squared. So first let me combine my like terms. So I have 8 plus 2i minus 3i squared. Now here is where it changes. This is what's different, because we know that I squared is equal to negative 1. And so this is really 8 plus 2i minus 3 times negative 1. So 8 plus 2i plus 3, and 8 plus 3 is 11 plus 2i. And that's the final answer. So you treat I like a variable the whole way through, but at the end of the problem, if one of your i's is squared, you swap or substitute negative 1 in for I squared. So again, here I'm going to FOIL. Notice this is a difference of squares. So this is going to be 3 squared minus b squared, right? Or the second term squared. So this is going to be 9 minus, it's going to be 4i squared. And again, 9 minus 4 times I squared, which that's negative 1. So 9 plus 4, or 13. Again, with this problem, we're going to FOIL. Remember that 3 plus 2i squared is really 3 plus 2i times itself 2 times, right? So again, first times first is going to be 9. Outer times outer is 6i. Inner times inner is 6i. And last times last is plus 4i squared. So 9 plus 12i plus 4 times negative 1, which is negative 4, right? So it's going to be 9, well, let me just write that the right way. So that's going to be minus 4, and 9 minus 4 is 5 plus 12i. There's your solution. And then the last one, again, we continue, we work on foiling. So first times first is 6, outer times outer is plus 6i. Inner times inner is minus 12i, and last times last is minus 12i squared. So again, I'm going to combine my like terms in the middle. And then minus 12 times minus 1 is plus 12. So I'm going to get 18 minus 6i. There's your answer. Remember to put it in standard form. So there's a section here they kind of added in here. They squeezed it in a little bit first, but I guess we'll just cover it. So complex conjugates. So this is when you happen to have an expression, right, that has an I in it. And so sometimes when you're trying to rationalize denominators that happen to have I in it, because again, you can't have I in your denominator, kind of like a radical, you have to multiply it by the conjugate, which we've done before, okay? So just remember that the conjugate is always, if the expression is 1 plus something, the conjugate is 1 minus that something. And so notice that when I go to FOIL this now, I'm going to have a difference of squares. A difference of squares is always the first term squared minus the second term squared. So 1 minus negative 1 is going to be 2. Okay, and so notice how as soon as we multiply by a conjugate, we completely eliminate the imaginary number. So again, this one is 4 minus 3i, so I'm going to multiply it by 4 plus 3i. Again, because it's a difference of squares now, it's 4 squared minus 3i squared. So that's going to be 16 minus, and then this is going to be 3 squared is 9, and I squared is negative 1. So this is going to be 16 minus negative 9, which is really plus, so it's going to be 25. And so again, this is when you're going to use conjugates when you happen to have I in the denominator, okay? So for example, let's say you just have 2 divided by I. Well, that's easy. You don't need a conjugate here. You're just going to do I over I, just like you did before with radicals, and you'll get 2I over I squared, which means 2I over -1, which ends up just being -2I. Now, if you happen to have, 2 over I plus 5, or it doesn't matter if I is first or second, but let's do it the right way. 5 plus I, right? You're going to multiply by 5 minus I, because that's the conjugate. And what will happen is at the top, you'll get 2 times 5 plus I, which you can distribute at another time. And down here, you're going to get 25 minus I squared, which is -1. 25 minus -1 is 25 plus 1. And so you'll end up with 26 down here. And again, you could then simplify, and it's 5 plus I over 13. But again, you're going to use your conjugate to rationalize denominators, okay? So again, I think this slide should have gone first. Denominators must always be rationalized, and to rationalize, you must multiply it by the complex conjugate. That's what that's called. Instead of just a conjugate, we call it a complex conjugate because it involves a complex number. So now let's do some problems that have that in it. So I start out here and I see that I have this conjugate or this complex number in the denominator. I can't have that, so I'm going to multiply by its conjugate. So instead of 1 minus I, I'm going to multiply by 1 plus I. My numerator is going to be 4 times 1 plus I, and my denominator is going to be 1 squared minus -1. So it's going to be 1 plus 1, which equals 2. So 4 times 1 plus I all over 2. And again here, I could simplify that. So my final answer is 2 times 1 plus I, like that, or 2 plus 2I. This is my preferred method. Okay? Now we'll go to the next one, and we get here, we have 1 plus I is our denominator. So we're going to multiply by 1 minus I and 1 minus I. So here, notice we're going to FOIL the numerator. We're going to get 1 squared, which is 1, right? We're going to get minus 2I plus I squared, okay? So again, our numerator is going to be 1 minus 2I minus 1. Again, notice 1 minus 1 cancel. So our numerator is going to stay minus 2I. So now let's work on our denominator, right? So over here now, I'm going to do this, but it's a difference of squares again. So it's going to be 1 squared minus -1. So that's 1 plus 1, or 2. So it's going to be minus 2I over 2, which again, notice the 2's cancel out, and you're going to get minus I as your final answer, or minus 1I. Let me do it with black, it's easier. So again, here I'm going to multiply by 4 plus 2I, again, always multiplying by the complex conjugate. And again, we do that because we're trying to get rid of the imaginary number in the denominator, which we cannot have. So again, when I FOIL the top, it's going to be outer time, or first times first, 8. Outer times outer is going to be plus 4I. Inner times inner is plus 12I. And last times last is going to be plus 6I squared. All over. And then again, this one's going to be 4 squared, which is 16, minus b squared, which is going to be 4I squared. Okay? So again, I'm going to just continue simplifying here. My top one becomes, my numerator becomes 8 plus 16I minus minus 6. And my denominator is going to be 16, and this is going to be minus 4, 16 plus 4. So I'm going to end up with 2 minus 16I all over 20. And again, you can simplify this as if there were radicals. Since all of these have a 2 that goes in them, this could become a 1, this could become an 8, and this could become a 10. And so your final answer could be 1 minus 8I all over 10. And that would be acceptable. Okay? We keep going. We still have a few more. So again, we're going to multiply by the complex conjugate, which is 5 plus I. We FOIL out the top, and we get 15 plus 3I plus 10I plus 2I squared. And our denominator becomes 25 minus -1. So when I go to simplify this, my numerator is going to become 15 plus 13I minus 2. My denominator becomes 26. My numerator, again, I can continue to simplify a little more. 13 plus 13I all over 26. And again, they all share a 13. So if I divide that out, I get a much simpler answer. It's going to be 1 plus I over 2. That's my final answer. And I'm going to do this last one. And again, I'm going to multiply by the conjugate, complex conjugate, 4 minus 3I, 4 minus 3I. Again, FOIL the top. I'm just going to do a little bit of shortcuts here. The top is going to be 16 minus 24I plus 9I squared. I combine those middle terms. My denominator is going to be 16 minus 9I squared. So again, when I come over to here, I know it's going to be 16 minus 24I minus 9. The bottom is going to be 16 plus 9. So 16 minus 9 is going to be 7 minus 24I all over 25. And I think that's it. So again, that's kind of how you do it. And the whole purpose of multiplying by the complex conjugates, again, is to eliminate I from the denominator, just like we do with radicals, because we cannot have them in the denominator. Again, I'm inserting this section because I realized I went from slide 6 to slide 8. So I totally skipped this slide, which is the one that really told you about pulling out I first. So you'll see it now in order, but it'll explain why the next slide goes into a little more detail than it needs to. So again, when you get here and you get a square root of a negative number, what you're going to do is, again, you're going to separate it into two, the products that made that, right? But one of those products is going to have to be a -1, or the factors that made it. So I can expand this out to make this square root of -1. I mean, I guess I would start it like this. I would do the square root of -1 times 3. Then this is the square root of -1 times the square root of 3. And the square root of -1 is I. So I radical 3 is your answer. Again, here, this is the square root of -1 and the square root of 16. So again, the square root of 16 is 4. Square root of -1 is I. We always want the number in front of the I, okay? So then we go to square root. We go to the next one. This is going to be -1 times 16 times 3. And so again, square root of 16 is 4. Square root of -1 is I, and then 3. Come over to here. Square root of -1, square root of 100, square root of 5. Okay, those are all the factors that make up -500. And then again, square root of 100 is 10, square root of -1 is I, and 5. And then we go to the last one. Now notice this one, it appears to have a negative on the outside, right? So this is going to be negative, or -1 if you want to see it like that, right? Then we're going to do the radicals. So we've got -1 times, let's do 16 times 5, okay? So again, the negative stays out here, right? And again, you don't have to put -1, it's just a negative, but I always think of it as a -1, but let's just keep it as a negative. Then the square root of -1, or square root of 4 of 16 first is 4, square root of -1 is I, and then 5. So the only thing that changes is whatever this is, this makes it the opposite of that. So if this ends up being a positive answer, then it's going to be the negative version, okay, or the opposite sign. And that's it for that. So now when we transition into the next slide, you can apply these skills. So now we're going to simplify radicals that happen to have negative numbers in it. Because again, remember that we used to not be able to do this. When we got here, we were stuck. And so when we got to like a square root of -7, we would say no solution and we were done. Well, now it does have a solution. The one thing that you cannot do is we taught you in the past that the square root of a times the square root of b equals the square root of a times b, that you could merge and unite those numbers. Well, that's only if those numbers happen to be positive. It doesn't work if those numbers are negative. And so I cannot just come in here and say, oh, that's the square root of -7 times -7, which is the square root of 49, which is 7. You cannot do that, okay? That is not a thing, all right? So what you have to do is treat them independently. So here now, this becomes the square root of, think of it as -1 times negative or +7, right? So we can kind of take out the -1 there. And so we're like, okay, well, what is the square root of -1? Well, the square root of -1 is I. And so that becomes I root 7, if that makes sense. So while I can break within the radical, I can break that into a negative and a positive number. I can't multiply negatives inside across them, okay? So that's kind of what we're saying. So anytime you see a negative number, you're just going to separate out the -1 from it. So you're going to have -1 and 7. So that's the square root of -1 times the square root of 7. Square root of -1 is I, and this is 7. So then you do the same thing with the next one. That's also the same scenario. So that's the square root of -1, square root of 7, and that's also going to be I radical 7. And now that you separated it into, now notice that inside the radicals you don't have negative numbers. You can now multiply like normal. So remember that when you multiply with radicals, the numbers outside get multiplied together and the numbers inside get multiplied together. It's 49. So again, I squared is -1 and the square root of 49 is 7. And so the answer here is -7. Okay, so let's keep going and do some more. We're going to come over to here. So as soon as I see a -1, I just take a negative inside. I just take the negative out and leave the positive number inside. Because again, it's a shortcut because I know that this is going to be -1 times 6 and the square root of -1 is I. And so again, I don't have to write that every time. I'm going to do it a few times just so you get in the habit. But at some point, you're going to want to drop that part of it, right? So I radical 10. So now what I'm going to do is I'm going to do I times I, which is I squared, times the square root of 60. So again here, I know that, let me just kind of go over here. I know 60 is 15 times 4. So the square root of 4 is 2. I squared is -1. And square root of 15. So -2 radical 15 is my answer. Keep going here. Notice here I've got the square root in the denominator. And again, before we learned, oh, we could just do -20 over 2 and simplify that and all that. Well, guess what? You cannot do that here because, again, they're separate radicals with negatives. So I have to simplify them first. Now, normally, I might come over to here and I might say, okay, I'm going to show you the traditional way we would have done this. We would have done -1 times 4 times 5. And my denominator, I would have done -1 times the square root of 2. So I would have gotten square root of -1 is I. I would have gotten the square root of 4 is 2, so I put it in front of the I. And then square root of 5. And then down here, I would have said the square root of 1 is I, radical 2. And then here I would have been left with this, and I would have said, okay, now I can simplify, right? Anything outside the radical can simplify, and anything inside can. So my i's would cancel, and I would get 2 radical 5 over radical 2. However, I can't have a radical in the denominator, right? So I have to rationalize that. So you would still have to come in here and do radical 2 times radical 2. You'd get 2 radical 10 all over 2. My 2's cancel. And my final answer is radical 10. And so that's a lot of work because I broke it all down here. And I'm going to show you a shortcut, okay? It's all correct. However, I'm going to show you a better way to do it. When you happen to have these radicals, first of all, we're going to start out by getting rid of the I part, right? We definitely want to get the I outside. So I'm definitely going to want to break negative 20 into the square root of I times something. But because my denominator has a 2 in it, I'm going to break it instead of into perfect square of 4 and 5, I'm going to do 2 and 10. Okay? Actually, let me even write it better. Let me do square root of negative 1, square root of 2, and square root of 10. And then when I go to the bottom, I'm going to do square root of negative 1 times square root of 2, right? Now, notice that I don't have to do a lot of math here. I don't even have to turn this into I, because notice I have this over this cancels, this over this cancels, because they're the same, leaving me with square root of 10. And so I didn't really have to do a whole lot here. I could have just done some simple math there. All right, so just kind of think about that when you're working, because sometimes, you know, we work harder but not smarter. So same thing goes for here. When I get to this problem, I know that this is the square root of negative 1 times. Now, I know 48, normally we do 16 and 3 because 16 has a perfect square. But because the denominator has square root of 24, I'm going to do 24 and 2 because I know that multiplies to 48. Then I go to the bottom and I just have the square root of 24. So notice this and this will cancel out. So the square root of negative 1 is I, and then square root of 2 is left over. And that's the answer. So with radicals, we can work kind of smart, right? So again, I'm going to come to this problem here, and I'm going to start out the same way. I'm multiplying here. So I know that this is going to be, again, I'm going to skip the square root of negative 1 part now. I'm just going to do I radical 5 times I radical 15. And when I multiply that together, I'm going to get I squared times the square root of 75. Now here, I know I can simplify that a little bit. I squared times the square root of 75. So this is negative 1, and this is 25 times 3. So negative 1, square root of 25 is 5. And so it's negative 5 radical 3. That's how we do it. Keep going. Let's get to our next one. Here we have square root of negative 70 over the square root of 7. So again here, I'm going to, I can again expand it out. I got negative 1 times 7 times 10 over square root of negative 1 times square root of 7. So notice I expanded it out. And the square root of negative 1, square roots of negative 1 cancel, the square roots of 7 cancel, and that just leaves me with the square root of 10. Again, keep going. I get to here, and I'm going to do the same thing. Square root of negative 1 times the square root of 20 times the square root of 2, all over the square root of 20. So these cancel. Again, the square root of negative 1 is I. Square root of 2 is left over. And that's it. That's my answer. And we keep going here again. And I can try to multiply this whole thing out. I don't know what's better, but let me just try to simplify first. So I'm going to get I square root of 12 times I square root of 6 all over the square root of 8. So this numerator is going to be I squared times the square root of 72 all over the square root of 8. So I'm going to keep going here. I squared is negative 1, and the square root of 72 is the square root of 8 times the square root of 9 all over the square root of 8. Right? So cancel that, and I'm going to get negative 1 times the square root of 9. Well, we know the square root of 9 is 3, so negative 3 is the final answer. And so again, the simplifying along the way will make it a lot easier, but as long as you learn to work with it, it's great. You know, You might even take, like, when I went to this problem here, you know, in like number 27, you might have just said, this is I radical 70, this is I radical 7. Notice the i's cancel, and then you can focus on radical 70 over radical 7. You know, for example, you could have done radical 7, radical 10 over radical 7. These cancel. You could have also, at this point, merged these now. 70 over 7 is 10. So again, there's a lot you can do, but a lot of it is based on separating out the i's first, okay? If I keep going here, notice I have an expression at the, or a product at the top. I have this number at the bottom. Sometimes I even have addition. I think this might have been a mistake. I feel that this here was not supposed to be a multiplication symbol, but rather an addition or a subtraction symbol like it was on the other slides or on the other examples. So I think I'm going to change this to something else. Like I'm going to make this, let's say I make it a plus. Okay, I think I'm going to go with that. So if I get here, -8 plus the square root of -128 over 4, the first thing I have to do is simplify that radical at the top. And so that radical at the top, I know, can break down into -1, 64, and 2. And I still have my denominator of 4, right? So again, it's going to be -8. And then I'm going to have plus square root of 64 is 8. Square root of -1 is I. And I get a radical 2 all over 4. And so again, because 4 goes into all of these, I can simplify them out by factoring that 4 out or dividing it by 4. So I'm going to get -2 plus 2 radical 2 over 1 or whatever. So that's my final answer. So when I get to 31, again, the same thing. I'm going to simplify that numerator, -9 plus, and again, I can already just put the I, but again, I'll just do it in pieces. So -1 times 9 times 2. That's going to give me that -18 all over 3. And so again, I'm just going to start chipping away here, right? I know the square root of 9 is 3. The square root of -1 is I. It leaves me with a radical 2. And again, it's all over 3. And because all the numbers on the outside of the radical are divisible by 3, I can factor the 3 out. And so my final answer here is going to be -3 plus I radical 2. And since it's over 1, I don't write that. Okay? And again, last one, we come over to here, and we're like 5 plus square root of -1 times the square root of 25 times the square root of 2. And over 10, right? So again, I do 5 plus, I'm going to do square root of 25 is 5, square root of -1 is I, square root of square root of 2 is there, and then over 10. And because all of them are divisible by 5, I can simplify. So I'm going to get 1 plus I radical 2 all over 2. Okay? And that's it. That's how we do these. So now we get to a little bit more complicated version of this. And again, once you learn to do it, it's not too terrible. But what happens when we have i's of a higher power? So there's long ways to do this, and there's short ways to do it. The long way to do something like this is, let's say you have I cubed, right? So you would say, okay, well, I cubed is I squared times I. And so at this point, you know that I cubed is -1I, or -I. And so, yeah, that's a one way to do it. And again, I could keep going. Like, I could do something like I to the 10th power. Well, I know that's I squared times I squared times I squared times I squared times I squared, right? So there's 4I squared. That, obviously, I add my exponents. It adds up to I to the 10th power. Each one of these is a -1, right? So I write this out. And you're like, okay, if I multiply -1 times itself 5 times, my final answer is -1. But this can be pretty tedious. Imagine if you get to I to the 100th power or something. So we got to find it. Believe we have to find a way to make this more effective, more efficient, right? And so this is the way that I do these, okay? So what I do for like an I to the 10th is I say, okay, I know a squared is -1, right? I know that's -1. Now, I squared to what power would equal I to the 10th? Well, I know I squared to the 5th power would equal I to the 10th because it's I to the 2 times 5 power, right? So it's equivalent to -1 to the 5th power. And I know that a negative number to an odd power gives me a negative answer. So if this is odd, it's going to equal -1. If it's even, it's going to equal +1, if that kind of makes sense. So that's one way that I might do it. So let's try to do some of these examples and I'll show you how I might do it. Now, I to the 5th, so now here I've got I squared, but there's nothing I can really raise it to get there, right? Because 2 times what is 5? I can't do that, right? So what I try to do here is then I break it up. So when the exponent is odd, I say, okay, this is I to the 4th times I to the 1st, right? Or just times I. And then I to the 4th, I treat as I squared to the 2nd power times I. So this becomes -1 squared times I. -1 squared is 1. So I know my answer is 1I. Okay? So we'll do a few. I think it'll become more apparent. When it's even, it's a little easier. So the even exponent, I squared, and I got to get to the 32nd power. Well, that means it's going to be 16 up there because 2 times 16 equals 32. So I know it's going to be -1 to an even power, which means my final answer is just 1. Okay? Now, I to the 33rd, that's a little harder, right? So it's going to be, think of it as I to the 32nd times I. And then I to the 32nd, I know, is I squared to the 16th power times I. So again, if I squared is to an even power, this part of it is going to be 1. So I know it's going to be 1I. Now, what happens when you have a negative exponent? Well, remember with negative exponents, the same thing. This is 1 over I to the 16th power, which I'm going to translate to I squared to the 8th power. So when, right, because 2 to the 8, 2 times 8 is 16, right? So when I have that, again, I can expand this out, -1 to the 8th power. Anytime I have a negative number to an even power, it's going to become a positive product. And so this is just 1. So keep going. When you practice it, you'll get really good at it. So again, this is 1 over I to the 101 power. I'm going to simplify that and make it I to the 100 times I, because I know that 100 times I to the 1 is I to the 101. And again, now I'm going to change I to the 100. I'm going to make it I squared to the 50 times I. So again, if I have, right, I squared, I know that equals -1, and I have it raised to an even power, I know the product is going to be 1. So my answer here is 1 over I. But remember, we cannot have I in the denominator spot, correct? And so what I'm going to have to do is rationalize. So I'm going to have to do I over I, and I get I over I squared, which equals I over -1, which equals -I in the long run. Okay? So again, I know that's weird. And then this last one we'll do, and again, it's I to the -102. So it's 1 over I to the 102 power, and then this is going to be I over I squared raised to the 51st power. And again, it's going to be -1 to an odd power, which means it's going to be -1 or just -1 like that. And that's it. Okay, so again, notice the different, answers, and notice kind of some of the appearances. Notice that when the number is odd, 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 notice your answer has I in it, okay? And then notice when your exponent is even, when I is to an even power, whether it's positive or negative, but when the exponent is even, notice that your answer is going to be 1, 1, or -1. Notice there's no I in your answer. Again, so the odd powers should be left with an I answer. The even powers, you should end up with no I in your final answer. Okay?